In this video, we are going to do 3 questions from the chapter probability and which is based on tossing 3 coins, right? 3 coins. Now, before we read the question, I'll suggest you to understand the sample space involved in doing this kind of question. First of all, you should know that how many coins are there. Coins, first of all, you should know that there are 2 possible outcomes, that is head and tail. So number of outcome is how much? 2. And then we will look for the number of trials. Number of trials or could be number of coins. It's all same. Is how many? 3. So therefore the total possible outcomes will be 2 raised to the power 3. That is equal to 8. Similarly, as you know that number of outcomes will always be same, but if there are 4 number of trials or there are 4 different coins tossed, the number of outcomes raised to the power 4, in that case it is 16. You will get it as I make the sample space. You'll definitely get it. So in our case, as we have uh, 1 coin and the number of trials is 3, so therefore it is 8. First I'll write 8 heads out of 8. Let's do the table. Let's make the sample space first, I mean to say. So first I'll write head over here. Like over here I can write head. 4 times I'll write head. As I said, half of 8, right? So half of 8. So 4 times head. 3, right? This is 3 times, 4 times. And then write 4 times tail. 1, 2, 3, and 4. Then you will be writing half the previous. That means now I'll write 2 times head. 1, 2, and then 2 times tail. 1, 2, then again 2 times head till this get exhausted, and 2 times tail. Now half of 2 is what? 1. So 1 time head, 1 time tail. Then head, tail, head, tail, head, tail. This way you will not forget any of this missing observation. Now we are ready to deal with the questions here. Let's begin with the first part. It says 3 different coins are tossed together. Find the probability of getting, the first part is what? Exactly 2 head. So look for the one which is exactly 2 head. It has to be this 1, right? So 2 and then 3, right? These are 3. I may circle it, that's better to understand. So these are, is that called? Yeah. This is 2 head. This is also has 2 heads, and this also has 2 heads. So therefore, the possible ways by which, not possible ways, we'll say that probability of getting exactly 2 heads is what? 3 is favorable, and total number of observation you will count 8. So that's how. Now, if I, and what's the second part? It says at least 2 heads. So what is at least 2 head means? That means minimum 2 head. It can have 2 heads or 3 heads. There cannot be 4 head in our case. So can have at least. Let's understand once again. At least 2 heads means 2 or more than 2, right? 2 or more than 2. So we will say we'll look for the one which having 2 heads or 3 heads. So this will go as it is: 3 head, 2 head, 2 head. This is not there. 2 head and no 1 head only, just 2 head, right? So at least 2 head. I'll once again explain you. This is important. That means with 2 heads or more than 2 heads, that is 2 and 3 heads. That's why I've taken those which is having either 2 head or more than 2 heads. So the required probability in this case, say PB, if I use the favorable, as you can see that there are 5 of them, sorry, 4 of them, and the total is 8. So that comes out 1 over 2. That is for the second part. Now check for the next, that is, if I see that at least 2 tails, same way we can do. At least 2 tails means 2 tails or more than 2 tails. In our case, it can be maximum 3 tails. So this is not possible. We will be looking for 2 and 3 tails. So this is 1 tail. This is correct, right? So this is 1. I'll write this side 1. And this is only 1 tail. We are looking for 2 tails and 3 tails. This is. So again, in this case, the probability will come as how much? This is 4 out of 8. That comes out to be 1 over 2. Now we'll move to the next question here. That is question number 2. So what is it all about? The next question says 3 distinct coins. Once again, same way. Find the probability of getting at least 2 head. We have already done at least 2 heads, right? So we'll not be doing this part. We'll be doing the next, which is at most 2 head. So this is different. At most means maximum 2 head. It cannot have more than 2 head, but can have less than 2 head. That is less than 2 head is 1 head. Even no head, right? Let's understand once again. At most 2 means maximum 2. So it can have 2, less than 2, which is 1 or 0. So in this case, we'll be looking for 2, 1 or 0 head, right? So this cannot be possible at it has more than 2 head. So this is true. True head, 1 head will go. 2 heads, 1 head is also true. 1 head and no head, right? All tails means no head. So you can see in this case, the required probability, if I say that is P A once again, as what there are 7 favorable observation out of 8. So 7 over 8 is the answer for this. Now I'll do the last part here. In the last part, what is it? It says a game consists of tossing 3 coins. Sorry, a coin 3 times is same as tossing 3 coins 1 time. Noting the outcomes each time. Hanif wins if he gets 3 heads or 3 tails. Right, this is the condition for winning, right? This is the condition for winning the game. And for the other, and loses otherwise. Calculate the probability. What we have to get is the probability of Hanif will lose the game. So lose is what? Loss is when he gets otherwise. Otherwise means except for this. Let's say. So he win when he is winning. Winning, I'm putting a cross over here, right? Because we are not taking winning, we are taking losing. So he wins if there are 3 heads or 3 tails. And otherwise, she win, she lose. But we are looking for our favorable is not win, right? Our favorable is loss because we are looking for the possibility of he losing the game. So we'll say that say PA is the probability. There are 6 favorable observation out of 8. So 6 over 8, that is 3 over 4. So this is the answer for this. We'll do more question based on this in the next video.